numbers, and we'll get started. Oops. I will put on mute for background sound. Well, there we go. Okay, everyone, let's get started. Our goal today, and it's going to happen one way or the other, is to finish 7-8. We still have a few things that I want to cover. Essentially, I want to cover 3 things. First thing I want to do is just go over a couple more type 2s. So some more of these. Then I want to look at I'm trying to remember the phrase here that they use, so I don't use a different one and I have to change the name. There we are. Going to look at what's called the comparison test. And then the last thing is we're going to look at type 1. So I've got no particular. Is anybody having trouble with any of the homework ones that are on the type 2 type? You know, the limit with an infinity in it, in the intervals. If not, I'll just pick a couple of my own. But if you've got one that was causing issues, I'd rather choose that as my example. Okay, I'll pick mine. It doesn't matter too much. I will choose a fraction one, I think, if I can find it. I think they're a little bit later in my list. Yes, they are. So this one is quite a long question. It's from 2 to infinity. And it's a 1 over v squared plus v take away 2 dv. And what I can tell by looking at that is that this is going to be a partial fraction question. And the factors are going to be what? Take away 2, add 2, take away 1. There we go. Looking good? Which means that I'm going to have to do the partial fraction part. And I'm also going to have to do this bit. This is going to be the limit as t tends to infinity of the integral from 2 to t of a over v plus 2 and b over v minus 1 dv. Be comfortable about that in this guy. Right. Now, over here is the working for finding a and b. This fella is missing a v minus 1. And this fella is missing a v plus 2. So we now have a v minus 1 plus b v add 2, and that's going to equal the top, which is 1. Are we cool with that? Okay. Give me a choice. What number would be a good choice for v?
1.
1 will work. If you do that, this guy's 1. This guy disappears. And you get 3, so we now know b is a third. When they're both linear like this, we don't need to replace the b with a third. It's not necessary. so I won't bother. Give me my second choice. We've done v equals 1. Who should I choose now?
-2.
Great. And if you do that, you get 1 again equals -3a plus 0. And that tells me a is -1/3. So we can now return here, and it's going to be the limit as t tends to infinity of 2et a, which is -1/3 v add 2 plus +1/3 v take away 1 dv. So far, so good. Now, we're going to have some algebra issues in a couple of lines from now, so be aware of that as we reach it. I don't think the integration itself is going to be too tricky. If you integrate this, you just get 1/3 the natural log of v add 2, and this guy gets you 1/3 the natural log of v minus 1, and we evaluate it at the start and finish. That's pretty straightforward. Now it starts becoming a bit messy. -1/3 the natural log of t plus 2 add 1/3 the natural log of t take away 1, subtract -1/3 the natural log of 5 plus 1/3 the natural log of 1. So this horrible mess here is the guy that we need to find the limit as t tends to infinity of. So I guess I could write one more line. It's 1/3 of this guy, add 1/3 of this guy. Take away a negative is add 1/3 of this guy. But why am I not bothering about the 1/3 log 1?
That's supposed to be a 4, isn't it?
What, this one here?
The natural log.
Which one should be a 4?
Before that. So it's 2 plus 2.
Oh, thank you. Right. Why am I missing out the log 1 thing? What's log of 1 equal? Right, so it's gone. Right, I'm now going to do a little bit of algebra, as we kind of warned. I'm going to pull out 1/3. Now that leaves me with negative that log, plus that log, plus that log. I'm now going to combine all of these guys into a single log. Any suggestions for what that single log looks like? And that means you have to use the law of logs, which some of you are more rusty, I suspect, than others. Tell you right now, it's going to be a fraction. And there's going to be obviously pieces on the top and pieces on the bottom. So I guess the decision is, where do the pieces go? Where does the t plus 2 go? Top or bottom?
Bottom.
Because it's got a negative log. Where does the t minus 1 go? Top or bottom?
Top.
And that's because it's a positive log. And for that same reason, won't the 4 also go on the top? So we are now looking at finding this fella. This guy isn't really ready for doing brute force. If I did, don't I just end up with a log of infinity over infinity, and no, that isn't one, right? We have problems with infinity. So what will I have to do is figure out a way around that issue. So let's take it in stages. What will 4t take away 4 over t plus 2 be when you make t infinite? Do you know what that would be? Because it is a number. 4, I see someone. 4. But how could I do that? Couldn't I do on its own a L'Hopital of what does this become when t goes to infinity? Or couldn't I divide top and bottom by t? Or couldn't I just use the shortcut that the leading powers tell you the answer? Well, whatever way I do it, it's 4. So the limit as t tends to infinity, 1/3 the natural log of 4. You don't need that anymore. There's your answer. So I found out what this was equal to as t went to infinity, and it's 4, and then the rest came out. So it converges. Anything about that you want me to talk about more about?
Could you explain that last step a little more?
Sure. I am only focusing on finding out what that piece is equal to. So I'm going to divide top and bottom by t. If I do that, it becomes the limit as t tends to infinity of 4, take away 4 over t, and 1 plus 2 over t. And then I'll do brute force, so it's 4 take away 4 over infinity, 1 plus 2 over infinity, 4 take away 0, 1 plus 0, there's answer 4. Or I could do the limit as t tends to infinity of the same thing. Only this time I'll do L'Hopital on it. And according to L'Hopital, you differentiate the top and the bottom, and you get 4. Or I can use the trick that the only thing that matters in a fraction like this is the biggest powers of t. And you see 4t over t cancels down to get you 4. So now I know that this piece here is 4. So 1/3 log of this is 1/3 log 4, and we're finished. We cool? Okay. So quite a long one, but kind of needed to do it. Next one's going to be a very short one, and then we can move on to the comparison test. I'll just do it. I can't remember what it was. 1 to infinity of sine squared alpha, the alpha. That's whatever the question is. There's a question like that in the homework. So it's going to be turned into the limit as t tends to infinity of 1 to t sine squared alpha d alpha. I need to find the integral of sine squared alpha. Well, that's not going to work. I'll have to use an identity, won't I? Because I can't do a u sub or anything else. And there is an identity for sine squared alpha, isn't there? There's 2, in fact, but one of them is the only one I want to use. Going to use that one. Which means that it's now the limit as t tends to infinity of a half, take away a half, the cosine to thingy, the alpha, right? There's a few lines to go, but I can tell you where this one's heading. Is this going to converge or diverge?
Diverge.
Diverge.
Yeah. And that basically going to cause the trouble. Actually, so's that, but that, what does the cosine of anything look like as you go to infinity? The answer is we don't know, right? It goes up and down. It has no fixed value or limit. So you're now going to do comparison tests. Does that guy converge? I don't need to know what it converges to, but does it converge?
Yes.
Yes. Again, I don't really need to know any numbers, if it has any numbers. What about 1 over x? Does that converge or diverge if you went through the whole process?
Converge.
Diverges. You get a log of infinity. Oh, technically speaking, there should be some numbers there, right? Diverges. You can check it out if you want, but it is a diverger. So here's the problem. For what values of p will this integral converge, and for what values of p will this diverge? Well, this here would be p equals 4, right, and it converges. Wouldn't 1 over x cubed converge and 1 over x squared converges? And would you agree that 1 over x diverges and 1 over x to the half, which is the square root of x, also diverges? So there's a kind of sweet point where it goes from things that converge to things that diverge. And the changeover point is at 1. So if p is less than or equal to 1, it diverges. And if p is greater than 1, it converges. So that means we have a very shortcut way of telling how these behave. Right, I'm telling you that one converges. If it's 10 in the top, does it still converge? Yeah. If it's 3 in the bottom, does it still converge? So it really doesn't matter what multiple of the thing. If the basic building block converges, won't any multiple of it also converge? Now, in this case here, it diverges. Would it still diverge if that was 9? Yes. Would it still diverge if that was 10 as well? And the answer is yes. So we can take away all the superfluous stuff, right? All the extra constants. And the basic shape of these types of functions is going to be 1 over x to the power of somebody. And depends on what the power is, whether you get a converging situation or a diverging. And what the comparison test does is it basically takes a function and it reduces it to a guy that looks like this, at least for some of the questions. So let's go for it. Suppose I wanted the integral from 2 to infinity of x cubed plus 4x plus 1 over x to the 5 minus x cubed. Now these questions only want, does it converge or diverge? They don't need to know what it converges to. You only need to make one decision, and that is it converges, or you hit the other dot, it diverges. Now, unfortunately, since there's only 2 choices and you get 3 in your homework, typically anyway, if you hit the wrong one, you know what the right one is, right? So try not to do that strategy, because this is actually helpful in other questions. So let me show you how you tackle this, or one way to tackle this type of question. I am going to look at this fraction, and I'm going to look at it as how it behaves when x is extremely large. Now, when x is extremely large, like a billion, trillion, billion, right? X cubed is the only part that really matters. Would you agree 1 billion cubed is massively bigger than 4 billion? And so you only take the leading powers on each case. And I call that process surgery. Now, what does x cubed over x to the 5 become? It becomes 1 over x squared. What do I know about this fella? Well, he behaves the same way that that guy behaves. Does this guy converge? I see a nod, and the answer is yes, it does. How do I know it converges? Because the power is bigger than 1, right? This power, 2, is bigger than 1. It will converge. How about would you agree on the top, the square of x is the biggest, the most important, and on the bottom it's x. If you simplify this down, don't you get 1 over x to the half? You agree? What do you know about this? Converges or diverges?
Diverges.
Because the power is less than 1. Last one of this type. The only guy that's important is 4x cubed. What's the important guy on the bottom? Actually, let me change that. What's the important guy on the bottom?
The 4x.
Okay. Now, the numbers don't really matter, so I'm going to ignore them. Doesn't this behave like that guy? And what do you know about that guy? Converge or diverge?
Diverges.
I think you said diverges. I hope you did, because it does. Because its power is 1. And if you're less than or equal to 1, which this is, it's a diverge. So do you see that we now have a way of finding out if something's going to converge or not by using comparison test? Now, in the questions you've got, you just hit one of the 2 boxes, but let me show you how I know it can help me. So, well, let's just make up a question. Let's suppose I wanted to know what this guy was. Right. Now, I could do this question. Oh, I need an infinity here, don't I? I could do this question just the usual way. Wouldn't I do a U sub, fight my way through a whole load of stuff and eventually get an answer? Or let's do a comparison. Who does this guy behave like?
One over x.
And does 1 over x converge or does it diverge?
Diverges.
So can I do this without having to do U subs in 5 minutes of work? Because doesn't diverge mean the end of the road? The question is finished. Now, if it was converge, so if I change this to a 4, this would behave like 1 over x squared. This means that it converges. I do not know what it has to converge to. You know, whatever, I'd solve it whatever way I needed to solve it, right? And then I could get my answer. But at least now don't I know which ones are worth doing the integrals for? Because I know there is an answer. And I can at least cut out some questions that I know are going to finish up as diverging without fighting my way through 5 or 10 minutes of algebra just to come to the same conclusion. So before I leave, let's put in some special cases. Oops, wrong thing. Imagine you did a question, you ended up with an inverse tan. That would probably come from a question that looks like this. Right, you end up with an inverse tan. Now, if you brute force this, which is really the only thing that you can do, you get that. And that is a puzzle. It could be 0, it could be infinity, it could be undefined, like a cosine, that kind of thing. But what is it actually? Do you know what the inverse tan of infinity is? Because it is a number.
Is it pi over 2?
It is, in fact, pi over 2, yes. If you do a sketch of the inverse tan function, it flatlines at both sides. And so as you go this way, can you see that that's going to be pi upon 2? And that is comparison test complete. So let's look at our third situation. We are looking at type 1 questions. So let's do this one as a starter. So how do we do type 1 in proper integrals? Well, we use a technique that we've used before. We just adjust it. When you look at this question, isn't the problem at x equals 4? Because there's a vertical asymptote there. That's what makes it a type 1, right? Vertical asymptote. So that 4 is causing us trouble. So what we do is we turn it into a t, and we make the limit as t goes to technically 4 minus, because it's a left-hand limit, because it's coming in from the 3.999 side, right? So that's why it says 4 minus. That doesn't really change what we do much, but it is there to be precise. So now I have this integral. And if I want to integrate that guy, I'm going to have to call it x minus 4 to the negative 2. And the reason I'm doing that is so I can use the power rule. In fact, I'm going to use the linear shortcut version of the power rule. Okay, linear shortcut. Or you can do a U-sub if you don't like linear shortcuts. So it's going to be the limit as t tends to 4 minus of add 1 to the power and divide by the new power. Evaluate at x equals 0 and finish at x equals t. Are you comfortable with the power rule being used here? Now, when I substitute in the boundaries for x, let's see what we get. Negative t take away 4 to the power of negative 1, subtract a negative, so I guess you add it. Negative 4 to the power of negative 1. Now, if you did that, can you see how ugly that is and how difficult it is to figure out what the things are? Suppose I did this. And I did a style point on it. Then what we are now looking at is the limit as t tends to 4 minus of -1 over t take away 4 plus -1. Oh, we've got a lot going on here. The negative of -1, which is +1 over -4. Whoa, there's a lot of negatives going in there. Just making sure you end up with a negative a core. It's a negative of a subtract of a negative number, which ends up being that fella. So don't really need that plus. Is this easier to see what's going to happen when t becomes 4 than trying to figure out what this is equal to? And so I'm trying to sell style points, right? Well, let's plug in 4, technically. -1 over 4 take away 4, subtract a quarter. So I kind of like brute force, don't you? Just plug in the number and see what you get. Well, that's going to be -1 over 0 take away a quarter. What's -1 over 0 or anything over 0, any number you like?
Undefined.
Okay, and when we use the word undefined, we typically, in this context at least, don't we mean it's undefined because it's infinity? It's infinitely large. So, and undefined works fine. Doesn't this mean that this one is divergent? Right? If the integral is a number, it converges to that number. If the integral is undefined or infinite or just not doable, you know, whatever we want to phrase, don't we use the word divergent in all those situations when they are? So it does have a fair amount of overlap, isn't it? Still limits with a t. It's just not t becomes infinity. It's t becomes 4 or 2 or 2 plus or something like that. Try another one. See if I can pick one from the homework. This one is, what question is this? This is number 17. And it's the integral from 0 to 11 of 1 over the cube root of 11 take away x. What value of x does this function have a problem with? What value of x does this have a problem with?
11.
11. And can you see it's also there, right? Which is what you'd expect, right? So that tells me that I'm going to do 11, the integral 0 to t. This is going to be turned into a fractional power because I'm going to use the power rule on it. What is 1 over a cube root going to look like when it's converted into a fractional power? One over a cube root.
-1/3.
Agreed. Everyone agree on that, right? Now, you can do this as a u sub. If you choose to do it as a u sub, it will be u equals 11 minus x. U subs are great and do them if that's what you feel comfortable with. but I'm going to do the linear shortcut method again. Mostly because it's quicker. Add 1 to the power. Great. Divide by the new power. Great. What about this 11 minus x? Does that have any effect on the answer?
I think we need to multiply by a -1.
Correct. If it was minus 5x, wouldn't we multiply by -1/5? If it was plus 3x, we would multiply by positive 1/3. Right. Now, this is going to be evaluated at x equals 0 and finishes at x equals t. But I'm not going to do it yet. I'm going to do style points, which means this guy is -3/2 the cube root of 11 take away x. Because if you're going to deal with anything involving replacing an expression with numbers, the style point version is going to be much easier to handle than
Do we
leaving
still
it
need
as,
to put a squared on that?
oh yes, thank you, than the fractional version would be. So it's now going to be the limit as t tends to 11 minus, right, the left limit, of -3/2 the cube root of 11 take away t squared, subtract this guy, which means you're going to add him, the cube root of 11 take away nothing is nothing, 11 squared is 121. I didn't say it was pretty, but it's doable, right? So 3/2 the cube root of 121. And now I can finish by plugging 11 in. Let's see what that looks like. The cube root of 0 squared. Would you agree 11 take away 11 is nothing, nothing squared? Wouldn't this just be 0? And so wouldn't the answer just be that ugly looking thing? But at least we know the answer now. This integral, right, the one that we started with, this integral converges to that number. So we've seen a type 1 that had an infinite answer, so that diverges, and we've now seen one that has a finite value, and that's a converging situation. Are we good? Happy? Okay. Got time for, well, probably one, maybe two, but it's pushing it to be two, but we could probably do one. Let's do this one. So it's a bit sneaky. There are no infinities here and here, so it's not type 2. And it doesn't have a problem at -2, and it doesn't have a problem at 3. So you might think, well, it's just an integral, just do what you always did. That would be a big mistake. This function does have a problem. At what value of x does a bad thing happen?
0.
And so what we need to do in this question is that we need to split it at the bad place. So to get the answer to this, we actually need to find two distinct answers. Does that make sense? How you deal with a situation where the bad value of x, the vertical asymptote, is not happening at the endpoints, but is happening at some value between them, in this case at 0. Now, I'm going to do these guys in a few seconds, but let's talk about what might happen. So can you imagine I could get infinity and the other one was also infinity, right? So that ends up being infinite. That ends up being infinite. What would we be able to say about the original in that case? If this was infinity and this was infinity, what could we say about this?
Divergent.
Technically, because it's infinity, but divergent is good enough. Can you imagine that this was infinity and this was 4? Right, so that one was infinitely big, but this was 4, right? For whatever reason it could happen, I guess, right? If that happened, what would the conclusion be this time?
Divergent.
Still divergent. If one bit's broke, the whole thing's broke, right? I could get 3 for this guy and a third for that guy. I guess that could happen, right? What would that give us?
Convergent.
And it would converge to what, 10 thirds? Now, can you imagine that the first answer was, for some reason, negative infinity, and the second one was plus infinity? I'm warning you. Trick question.
Still divergent.
Still divergent. No, it's not equal to 0, because one version of infinity could be bigger than the other, right? Infinities don't play well very often when you try and subtract them, right? In fact, I'm about to do this question, but let's just say that I do this one and it ends up being infinite. Do I actually need to spend any time doing the second one? Or can I just say, if one bit's broke, the whole thing's broke, so it's divergent? Okay, which one do you want me to do? This one or this one? Left or right?
Right.
Okay, so I'll focus on this fella. Great. So it's going to be the limit as t tends to 0 plus of the integral from t to 3 of that guy, which is the limit as t tends to 0 plus. Power rule, add 1 to the power, divide by the new power, and it's going to be evaluated at t and at 3. It's going to be the limit as t tends to 0 of negative 40 over 3x cubed Okay, do my little style point then. That becomes the limit as t tends to 0 of negative 40 over 3 lots of 3 squared. Take away a negative, so add 40 over 3 t cubed. Okay, that's 27. And this guy ends up being nothing, doesn't he? 4 times nothing cubed is still nothing. What does 4 over nothing get you?
Infinity.
Infinity. Undefined was fine. Infinity is fine. So doesn't that mean this diverges? And if one bit's broke, the whole thing's broke. So that means that this question is now finished as diverges. So in your homework, there's a box and you type in diverges and you move on. Now, there isn't a comparison test that you're going to find out about, at least for type 1. It's not worth even trying to discover one. The comparison test is really what happens when X is really, really big, right? It's designed for comparing things that way. You can't really talk about these questions because isn't the place where things go wrong keeps changing? It's 1, then it's 4, then it's 2, then it's 0. And secondly, the way it changes is hard to predict. So if you were wanting a comparison test for this as well, sorry, don't look for one. Right. You just have to do the question from scratch. Of course, if 1 bit is infinite, right? Then you're finished, right?